So hello guys and welcome to my channels. Today again I am back with another important numericals and basic electrical engineering. So here on the screen you can see a numericals, and here in this numerical we have to calculate the current through galvanometers in the bridge circuit as shown in the above figures. Means here we have to calculate the current through these galvanometers. So first of all, here we need to show the current distributions in the network. So for that, suppose the current following in this is I, and here the current following in this branch is I1. This is I1. Similarly, the current following in this branch is will be, suppose this is I2, and here this is I1, this is I2, and suppose this the current following through this galvanometer is I3. This is I3, and the current following through this branch will be, and here this is I1 and this is outgoing I3. So obviously here you can write the current following through this branch will be I1 minus I3. So it will be I1 minus I3, I1 minus I3, I3, and here the current following through this branch will be, here you can write, since here I2 is incoming current, here similarly I3 is also incoming current, so its outgoing current will be the sum of I2 plus I3. So I2 plus I3, and now here first we need to apply the KVL here. Applying KVL to mesh A, B, C, A. Here A, B and C and A. Suppose the current is falling here with this is mesh 1 and this is mesh 2, and here we have assumed this as mesh 3. So in this mesh, if we apply KVL, here we have A, B, C and A. So applying KVL to mesh A, B, C, A, we can write here. So here we can write I1, here we can write minus I1, and this will be minus I3, and similarly this will be minus this will be positive I2. So here this is 1 ohm resistor, so minus I1, and here we can write this is a 2 ohm resistors, and again this galvanometer has one thing here, 4 ohm. This galvanometer has the resistance of 4 ohms. So if we apply KVL in this mesh, then you can write minus, this is 1 ohm resistor, so minus I1, and minus I3 into 4, so minus 4 I3, and this will be plus 2 I2. So here on applying the KVL we can write here minus I1 and minus 4 I3 and plus 2 I2, and that is equals to 0. Since in this mesh here my 1 into this 1 ohm resistance, so minus I1, and since the current is flowing in this direction, so minus I3 into this is 4 ohm. Galvanometer has the 4 ohm resistors, 4 ohm resistance given, so minus I3 into 4, and again this current is falling in this directions, but here we have assumed the mesh in this directions, so it will be plus 2I2, so 2I2 equals to 0. So here this is, suppose this is equation 1, and now applying KVL to mesh B, C, D and B. So here if you apply KVL to mesh B, C, D and B, means this B, C, D and B means this mesh, and suppose the current following in this mesh is in these directions. Here you can see this is in these directions. So here on applying KVL we can write here, so for this we can write, since this is in anti-clockwise directions, so for this we can write, if we start from here, so this is 4 ohm resistors, so minus 4 into I3 and minus 3 into I2 plus I3 and plus 2 into I1 minus I3, since the current is in opposite directions here. So here we can write minus 4 I3 and again minus 3, and here we have minus 3 I2 plus I3 given here, so I2 plus I3, and again for this 2 ohm, so it will be plus 2 I1 minus I3, so it will be plus 2 I1 minus I3, and that is equals to 0. So here on further simplification we can write here, so if you solve this we will get the equation in terms of I1, I2 and I3, so finally we will get here 2 I1 minus 3 I2 and minus 9 I3, and that is equals to 0. So this is our equation 2, and now applying KVL to mesh A, C, D, A, means A, C, D and A, and here we will assume this as a mesh third here, and the current is following in these directions here in this way. So this is our mesh third. So here if we apply KVL to this mesh, so here applying KVL to mesh A, C, D and A, here we are applying KVL to mesh A, C, D and A. So on applying KVL we can write the equation as here, so you can write minus 2 I2 and again this minus 3 I2 plus I3, and this is plus 2 volts, so plus 2 equal to 0. So you can write here minus 2 I2 minus 3 and I2 plus I3, and again plus 2 volt is also given, so plus 2 and that is equals to 0, and here we have applying KVL to mesh ABCDA. So here we have assumed minus, here this is I2 current, so minus 2 I2, and this is through 3 ohm resistor given here, so minus 3 into I2 plus I3, and since the current is following these directions and here the current is leaving from positive, so plus 2, and that is equals to 0 here. So here this is our equation third. So this is our equation third, and here let's simplify this first. And here if you further simplify this, we'll get here on further simplifications we can add minus 5 I2 minus 5 I2, and again minus 3 I3 and plus 2, and that is equals to 0, or simply we can write here that is equals to minus 2. So this is our equation 3. Now here I1 term is missing here, so simply we can add 0 into I1. So here you can see equation 1, equation 2 and equation 3, these are in the term these are in the form of I1, I2 and I3. So simply you can solve this equation 3 equation with the help of calculators. So once we solve this with the help of calculator, we will get the value of I1, I2 and I3. So here on solving we will get the value of, so here on solving we will get the value of I1 as, here I1 will be 15 upon 22 ampere. Similarly here the value of I2 will be, IT is going to give here 17 upon 44 ampere, and the value of I3 will be here, I3 is equals to 1 upon 44, and this will be in ampere. So here finally we have obtained the value of I1, I2 and I3, and here we have to determine the current through this galvanometer. So this is I3 current is falling through galvanometers, so the current through galvanometer is I3, and this is I3 equals to 1 upon 44 amperes, so which is our required answer. So in this way you can calculate such type of numerical problems. Hope you enjoy the lectures. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.